Okay, let's give you guys a problem to solve. So find this purple area here. Find this purple area here, and this distance here is A, and this distance here is A. So find the purple area for given A. So press pause and have a go. Okay, so to do this, we need to come up with the equation for the circle. So realize that, well, if you have a circle that passes through the origin, and this distance must be of the same length as this distance, there can only be one circle, and the center of the circle must lie somewhere on this diagonal line, because it's symmetrical. It has to be symmetrical because this length must be of the same length as this here. So you could argue that you can have a big circle like this. You could argue that you can have a big circle, but the thing is, it won't be symmetrical. The center of the circle will be somewhere down here, and this length is not the same as this length. The point here is that if you have a circle that passes through the origin, and this length must be the same as this length, then the center of the circle must lie somewhere along the diagonal, and there can only be one and only one circle where this distance is of the same length as this distance and it passes through the origin. There can only be one circle, one and only one. So the next question is to find out where well, we know the center of the circle must lie somewhere on this diagonal line. We've got to find out where the center will be, and the radius of the circle as well. Well, it turns out, if you think about this, we know that the center must lie somewhere in the diagonal length. As it turns out, the center lies right here, where this distance must be the same as this distance, must be the same as this distance. So well, if you hang on, you've got this thing here. So this is so to find the center of the circle, we've got to find out the radius first. So let's find out the radius of this circle. So this triangle here is the same as this triangle here. Our job is to find out the radius of a circle, which is this length here. So that's the radius of the circle. So use Pythagoras, where, well, the radius turns out to be this. So now we know the radius. So we know the radius, and the center of this circle, well, the center of this circle is half of A, and if you look at the height, it's also half of A. So to come up with the equation for this circle, let's start out with x squared. With x squared plus y squared equals r. We know that the radius of the circle is this. And now square this. That will then give us this thing here. And don't forget, we need to move the circle. Hang on. So we start out with a circle like this. We need to translate it across by a over 2, and then we need to drag it down by a over 2. So we need to do this. We need to drag it across. We need to translate it across by a over 2, and we need to drag it down by a over 2. So you need a plus here and a minus here, and the radius of the circle is given by this. So that's a squared over 2. So far the equation of this circle in Cartesian form is given by this. Now we need to convert it into polar form, and then we can integrate it. We can then integrate this thing here. So our next step is to translate this into polar form. So multiply this out, square this. That will then give us this thing here, and then square this. That will then give us this thing here, and then tidy this up. You've got half here, and you've got half here and a half here. So that if you merge these two together, it will then give you this thing here, and then this thing plus this thing will then give you this thing here, and then if you merge these two together, well, these two blocks here, if you merge them together, that would be the same as this thing here. So really these three will cancel each other out. giving you this. So now to convert it into polar form, you must know these three here. Always keep an eye out for x squared plus y squared, x squared plus y squared, so you can replace it with r squared. So these two is r squared, and then put this into the x. That will then give us this, and then put this into the y. That will then give us this. So whenever you demand that this whole thing equals 0, it will then draw you that circle. But then here, let's factor out. You got r here, you got r here, you got r here, so you can factor out the r. So you demanding that this thing here equals 0 will automatically draw that circle for you. But well, you demanding that this equals 0 is the same as you demanding r equals 0 or r equals this thing here. So whenever you make r equals this thing here, you will in effect you are actually in effect demanding this. Well, if you're demanding this, then you will automatically draw the circle. The point here is that if this is equal to 0 or this equal to 0, then you're going to draw yourself that circle in polar form. So in polar form, this circle here is given by this. So now we need to understand what's going on with this circle, because the angle is increasing like this. If let's say the angle is here, currently here, this thing here could be a negative, in which case it will draw in this direction, or when you're moving around like this. So let's say you're at this angle here, the r could be negative. Well, this is positive here. Negative would be down here. So you really need to understand what's going on. I will continue in the next video. Okay, so we are currently at this stage here. We need to understand what's going on with this circle, because when it comes to polar form, all sorts of things could happen. Because if you're at this angle here, it could give you a negative radius, so you don't know what it's doing, so you need to investigate. So I will continue in the next video. Okay.